I'm going to talk about the OpenTelemetry tracer plugin. So this is one thing that we open source like a little bit earlier in the year for that. So just a little bit about what it is trying to do is trying to do something what we call the distributed tracing. So in a nutshell, what it is in the microservice world, when you make a API call, it's actually composed of many small microservices. So you make a call, and then A may be calling B, B may be calling C, and then wait for the result for C, and then call D, etc. So that's like a whole network of microservices in your enterprise, and it is actually really good if you can try to do some tracing of your microservice and be able to plot a graph like this, and tells you what are the things that goes wrong along the way for your API call for that. All right, so there's a lot of software that is available in the open source that can help you to do this. There's Jaeger, Zipkins, Lightstep, and I think Apache Skywalking is also doing that too. And so there's so many vendors. So there's somebody who come up with this project called Open Tracing, in which it tries to provide like a vendor neutral APIs and instrumentation library for distributed tracing. But it's deprecated in 2020. That's because they want to combine their effort with open census, and then they come up with a new project called OpenTelemetry. So this is like an incubating project for CNCF. So they combine all these things into what they call the telemetry data. And so that's compiled of metrics, logs, and then the traces, as we said. And I think they are adding more definition to what they mean by telemetry data as well later on. But anyway, so one of the really cool things like from the OpenTelemetry project is that they come up with something called the collector. So when you write your applications and you have your telemetry data, whether it is metrics, logs, or traces, then you send it over to the collector. The collector is composed of like three things, like the receiver, the processor, and the exporter. Receiver is like you can define the collector to be able to receive the data in various different formats or different type of mechanism. And then the processor will be allowing you to like filter some things or make some changes to the logs, etc. And the exporter can export it to different like formats, so that now it's no longer vendor dependence. Like Jaeger has their own format, Elasticsearch has their own format. There's various different vendors coming up with their software that you really don't care. As long as you have an exporter for that, then it's going to work. On the right-hand side, it actually shows a little bit about where the collectors can actually be deployed. Where often you have to deploy the collectors in probably your own cluster, and then have your application send the data directly to the collector. That's what they call the gateway methods of setting up a huge cluster to just collect all the data. There's also another type of deployment is what we call the collector agent, in which we try to deploy the collector that is closer to your application, so that the connection between your application to your collector is really close to each other. And then that one is going, that localized collector is going to actually send the telemetry data to somewhere else that they would please for that. So that's two different ways of deploying your collector for that. And so what we did is OpenTelemetry is, like, as I said, deals with the telemetry data. So that's comprised of metrics, logs, and traces. But we only care about traces in this particular plugin because I want to enable distributed tracing within the place I work. And so we come up with this thing called the OpenTelemetry Tracer plugin. So we only deal with traces. So there's something called the OpenTelemetry C++ library. So we actually, most of the code just like we use what the library provides us. We didn't write anything that tried to do anything too raw for that. And so we read incoming B3 headers. I'll talk about this B3 header. It is what we call the propagation headers. So we read B3 headers in the transactions, and then knows that whether my my client, do they have already initiated a trace or not? And if it is, then I should participate in that particular trace. If it is not, then I'm going to create my new traces and then add new B3 headers into the request to the origin that I'm forwarding the request to for that. And so at the same time, the ATS will also send trace informations to a OTLP endpoint. So OTLP stands for OpenTelemetry protocol for that. All right, so a really quick demo. Let's see if I get this right. So I have set it up on my laptop with 4 interesting, is it? I don't know how to improve the font size for this. But anyway, so I have 4 Docker containers here. And then so I have the collector running, and then I have my Jaeger actually connecting to the collector. And then I set up 2 ATS to actually talk to one another. So I have a first level ATS that will talk to the second level ATS. And then the second level ATS will send the request to destinations, which is HTTP beam. I'll show a little bit of the configurations. And so that's kind of the application flow. And then they would send telemetry data to the collector as well too. So this is what I have. And so this is the first ATS. So we can. Yeah, so I'm in the first ATS, I'm just sending a test.com request to another Docker container that is exposing the service in the 8081. And then in the second ATS I have, then I am actually going to show that. So it is just taking anything from 8081 and then send it to httpbeam.org for that. And so both of them actually has the plugin up and running. So in this case, in the second ATS, what we have is that we turn on the tracer plugin, and then I'm saying that where's my collectors is collecting the information, and I'm saying what's the name of my services. And in the first one, I have a similar things, turning on the plugin and then doing this, but with a different service name for that. So now when I am running a request to test.com, and then it will actually go all the way to the HTTP bin. And so since I'm trying to retrieve all the headers in a request, you can see that we have the B3 headers that is used to propagate the trace information across the different microservice calls for that. And so once I did that, I can see this in my Jaeger that I have exposed it on my pod for this. So I have it here, and you can see that I can do a query of the traces I just have. So this is how it is going to look like. So my media edge service actually just call my medium data center service, and then I know that the whole thing costs like 608 milliseconds, and then the second call is actually costing like 500 milliseconds. So this is like really, really simple examples, but is immensely and tremendously really useful when your microservice network is really like complicated, and we have much more like a graph that we can generate in this way for that. So that is the demo. Let's go back here. And so this is just the beginning. So I just put it out there in the open source, but there's a lot more things we can do with it. So right now I just choose the B3 headers as the propagation headers. But in the wild world, there's many different type of propagation headers that we can use. So I think Jaeger is from Uber, so they have this Uber trace ID, which is what they use as the propagation headers. I think trace parent and the trace state is a different software that they use that as their propagation headers. And then the plugin is actually requiring that we are sending the trace informations to a OTLP endpoint. So there's a lot more options we can add, such as timeout, and then you can also make it as encrypted with some security with the TRS settings. And optionally, we can also support more different type of exporters for our plugin. We don't have to send it all the way to the to an OTLP endpoint. We can send it to just a local file, stream the output into a local file, or you can send it to different type of exporter you want as well too. And I have each of the trays, as you see here, we call some of the notion is that this whole thing, we call it a trace. And then each of this small block is what we call a span. So you can look at the span and then look at information for each of the span. And then we add a lot of information, like what's the URL, what's the method, what's the status code, user agent, etc. And so there's a lot more information we can add here. And I only add really basic information. So we can actually keep on adding more to that. So that's it from my side. Any questions? Real quick. Yes.
How much was the overhead?
How much was the overhead? That's a really, really good question. The overhead can be a little bit overwhelming, but two of the things the OpenTelemetry people introduce is that one is the sampling rate. So when you do the tracing, you can say, I don't want to send trace information all the time. I can only send it for just 1% of it. So you can, the library allows you to do that. And we make it part of the plugin parameters. So when you turn on the plugin, you can say what's the percentage of the request you want, the trace information. Second things the community told me a little bit about is that when you're deploying, you can choose to deploy your collector really close to your application. In our case, let's say if we're deploying ATS in a Kubernetes in a container world, and then we should have the collector as part of the pod of that particular part of the as a sidecar container of that pod. So then the connection will be just on the local host, and they're saying that that will actually help to ease some of the concerns about your resource consumptions when you're doing too much tracing information for that. So that's two answers that they gave me when I asked about this. The library itself is responsible for like doing connection pooling as well as like setting the timeout, etc. for that. So we basically do nothing other than to just say, hey, I got a request. Let's just call it OpenTelemetry library and do all the things I want in this. Yeah. Cool.
Yeah, I was asking the question because some of you may know I proposed a similar thing with open tracing. Yeah.
Yes.
And when I tried that, and the use case is a bit different, but when I used that, I had to create some kind of context object for each thread to reduce the overhead, because if you have one context, then there will be blocking.
Yeah, in the OpenTelemetry world, I think they improved that a little bit. So that what I did in the plugin is that when the plugin starts, I just create a data structure that is given by the OpenTelemetry library. That's what they call the provider with all this information. And so all the requests coming in, so then we call the read request hook, and then we'll just be saying that since you already have the provider data structure, then you can just create a span using that and let that data structure to manage all the context. So they gave all the facility for you to manage it in this way. Yeah. Cool. Yeah, the code is actually really simple, and so feel free to take a look and ask me questions in the Slack if you want. Yeah. Cool. Any other questions?
Thank you.
Yes. All right. There's a lighting.